In this lesson we're going to describe the basic principles of heat transfer, and then in the following lessons we're going to look at different mechanisms for how heat is transferred in a solid and in a liquid and in a gas. So first of all, what can we say about heat transfer? First of all, that heat is always transferred from a higher temperature object or substance or material to lower temperature surroundings. So it always goes from a high temperature to a low temperature, never in reverse. So for example, if we've got a cup of tea here sitting in the kitchen at, let's say it's at 60 degrees Celsius, that's a hot cup of tea, and the temperature of the kitchen around it is 20 degrees Celsius, then heat will flow from the tea, from the cup, into the surrounding environment. It will never go from the surroundings into the cup. And that heat will flow until the temperature of the cup reaches the same temperature as that of its surroundings. Right? So heat flows until the object has the same temperature as its surroundings. And when that has happened, we say that the cup or the object is in thermal equilibrium with its surroundings. Okay, so what else can we say about heat transfer? Well, another important point is that the speed at which heat is transferred from a hot object to a colder environment depends upon the temperature difference between the two. So if we've got a kitchen, for example, which is at 20 degrees ambient temperature, 20 degrees Celsius, and we've got one cup on the table which is at, say, 30 degrees Celsius, and another cup on the table which is at 60 degrees Celsius. The cups are identical, there's the same amount of tea in each, and we can say that heat will flow at a faster rate from this cup because the temperature difference between it and its surroundings is greater. So here we've got a temperature difference, let's write delta T, that means difference or change in temperature equals 40 degrees Celsius, and here it's only 10 degrees Celsius. So we're going to get a faster flow of heat from this cup than we are from this cup. So we can say that the rate of heat flow depends on the difference in temperature. Now we might be talking about heat flow in a solid, for example. If I'm heating up this metal conductor, say it may be a steel bar, for example, I'm heating it up at this end, and the temperature at this end is obviously it's going to rise. So let's say at this end of the bar we're at 600 degrees Celsius, and at this end we're only at 20 degrees Celsius. Well, again, heat will flow along the bar. In which sense does it flow? Well, the same principle. It will always flow from hot to cold. So heat will always flow from hot to cold, and the greater the difference in temperature between this end and this end, then the faster the heat flows. In the next few lessons we'll look at the mechanisms for how heat flows through solids, liquids and gases.